Good afternoon, everybody. It's 1 o'clock here in Chicago. I'm seeing people are still logging in, so we'll give it just a minute. If you didn't join us for any of the webinars this morning, my name is Bill Gens. I am the Sales and Technical Director here at TopSolid USA. I'm joined by Joe Hart, our Technical Manager, and Mike Kay, our Sales Manager. If you have any questions during any of this presentation, please feel free to type it in and we will do our best to answer them. Alrighty, let's get going. So this afternoon, we're going to be taking a look at 3 more aspects of new features and updated features in TopSolid design. We're going to start with assembly, we're going to talk a little bit about families, and then finish up with bill of materials. This one will probably last 20 minutes, 25 minutes, something like that. So here we go. Let's go to assemblies. So right off the bat, we have made positioning a little simpler with some automated positioning and then some automatic dimensioning as well. The automatic dimensioning is what I'll start with. Basically, this command has existed for a while, the enclosing box command for calculating the enclosing area of a part, an assembly, whatever. But now it's possible to use this to help drive the overall size of an assembly. Okay. And then with the automated positioning, we've added all of the destination absolute planes, origin points, frames, and axes in the drop-down menu, so you don't have to have them visible to select. This was requested by a lot of TopSolid CAM users, actually, around the world. So I'll give you a show and tell on that one. So if I go into, minimize some of this, sorry. Go to my positioning here. So we have a part, right? So this part's in here, it needs to be positioned. So if I edit my positioning, it's under constrained right now, right? If I go to my constraint positioning and I choose this face, I don't have any planes or axes or frames or nothing on the screen to position to, so it's a little confusing for a novice user or, you know, even people that use it all the time. So under destination, we've made all of those standard planes, axes, and whatnot available. And you can see as you mouse over them, they highlight on the screen anyway. So maybe I want that to be attached to the XZ plane. Perfect. Maybe I want this now to be attached to the YZ plane. Nice. So now I have a degree of freedom here. And maybe I want that attached to the XY plane. And now it's positioned, but what you didn't have to do, you didn't have to go to your entities tree and go turn on your frames and planes and whatnot to get there. Okay, so again, a nice little improvement, but a good functional one. All right, let's keep going. Next, curved and operated extruded bar properties. So the long and the short of this, there is a property that's automatically set now on extruded components on whether or not operations are applied to it and whether or not it's a curved bar. Why? Because then you can use this to identify in the bill of material if there's additional operations that need to be detailed. If it's curved, it needs to have a better detailed print, for example. And this can show up in your bill of materials now and help guide the creation of these documents. Okay? And if we go look at the sample, it's here. Okay, so this first bar here, if I do a in-place modification to it, right? So I'm looking at it like I'm in-place modifying it. And I go up to my analysis stage and go into operations. You can see that the operated is true, curved is false. Okay? Again here, same concept. If we go look at this in the analysis stage, true and false. Okay? And if we go find a curved bar, let's go just open up the curved one. Locally modify that. We'll look at the analysis stage. Curved is true this time, operated is not. Okay, so again, it's just a way in this, like I said, this property can show up in a bill of material. Let's get out of here. Okay, whether it has complex trimming or not, can show up in there. So again, it's all about helping to document and keep things moving in a good direction. All right, so here we go. Keep on going. All right, extruded bar, possible length and profile of extruded bar. So you can create and abuse the extruded bar command to do all sorts of fun things. Okay, so the extruded bar doesn't have to be just a hollow tube extrusion. It can be a complex profile. Okay, think of an extrusion like this that might be for a window, right? And that window might have some kind of gasket in the middle to seal the glass against. So there's a couple improvements this year. First improvement is the fact that you can specify potential default lengths. Okay, I'll talk about that more in depth in a sec. And you can also build, let's call them extruded subassemblies, full of multiple components, multiple extruded components, okay? That will act like the extruded components, that will document like the extruded components, that will trim like the extruded components, but it's in fact a subassembly. So instead of having to put in this separately, and then this separately, and then this separately, you can do it all at once. Okay, so again, super, super awesome improvements. So let's have a look. Solid here. Let's go to our possible lengths. Okay, so first, let's talk about how extruded components work. So when an extruded component works, by default, the software creates a component when you add it into your assembly and makes it 100 meters long. And then it trims the component to the length of what you asked for. The problem with this is you start getting into let's just call it calculation time issues, because we're creating, in many cases, a lot more of a part than is needed. So in this case, what we're going to do instead is we're going to help the solution and give it possible lengths to work from. So if we go to our parameters and we go to length, okay, we can just edit that. And again, this is just a length parameter that's driving it, right? I've gone in ahead and I've added possible values of 3 meters, 6 meters, and 12 meters. Okay? Now, when I'm done with that, update my family. I go to my drivers here and check the length there. And notice I have possible values there too. That will automatically be inherited. If they're not inherited, you can type whatever values you want for the family. But if you want to inherit them, they come from that driving part file. Okay? Now, this will all make sense here in a sec. Next, let's open our assembly. And I'm going to include one of these components. Okay, and I'm going to say it's on a frame and it's going to have a length. And I'm going to say the first length is going to be 1800 or 1.8 meters. Okay? And we'll say okay. And sorry, let me put the screen here. There it is. Now, if I go look at the family, you'll notice it made a 3 meter version of this part, but it then trimmed back to my 1.8. Okay? Now, if I go and modify this, or create another one, or whatever, it doesn't really matter. And now this time I say 3,300, right? Or 3.3 meters. So obviously that got bigger. And here, again, now it's creating a 6 meter version of the part that it's modified. And again, this was an optimization to help speed up the performance when using extruded components, let alone complex extruded components. Okay. Now, when it comes to the subassembly that I just spoke about, okay, let's go in here. We can go ahead and include one again. And you'll notice here, again, it can be however we want. It can be between 2 points if we want. I can say between point A and point B, right? And you're seeing it in there. It's adding my component. I can change the orientation of it so you can see it more clearly, but it's adding the several different components all at once, Whereas before you'd have to do this one, then this one, then this one, then this one. So it's just a way to speed up the creation of your assemblies defined by extruded components. There we go. So I saw a question in there about what happens if you create one that's longer than the available lengths. Let's find out. I honestly don't know. So let's go in here and back to these default lengths, right? So I'll go back to here to my absolute frame. So if I do 8,000, for example, and you see it's starting to get longer. Takes it a second. It's got to create the component first. There's our 8,000. We'll go ahead and create that. That's going to be from a 12 millimeter, or pardon me, a 12 meter long standard. And so the question is, what happens if we go beyond 12 meters? So let's go find out. So if I go edit here, and let's go to 14,000. I believe it's still going to create the component, but I think this time now it's going to go to the 100 meter and process it backwards. And you can see it's taking some time. So if you are needing to go to that, I would go and modify those standard lengths as well. Okay, so we'll let that crunch out. We'll continue talking. All right, next, in assemblies, we have distribution with vertical orientation. So this one's primarily for a newer product that we released about 2 years ago called TopSolid Steel. It's for working with structural steels to make, staircases, railings, whatever, for construction, right? And if you've ever used the distribution duplication method in our assemblies, it was missing something very, very important, which was a vertical mode. So again, we're making a railing going up an inclined plane like that, and the railing pieces are coming up perpendicular this way, which is not what you want. You want them to be relative to this axis. So now the improvement is you can do that. Okay, and let's see, is our other thing done crunching out? No, it's still thinking, so we may have to come back to that. Good job, Mickelson. Good question. All right, so all it is a switch in the dialog box to switch to vertical mode, and you choose the orientation that you're at. Okay, and then finally, a little improvement on in-place parts. Basically, in your part template, you can define a default command to be used. And this is in your document options for when you're creating a in-place part. So for example, if I select a planar face, when I create my in-place part, it's going to automatically go into my constrained block command. Okay, this command, in this case, this command is good for the woodworking industry. If I pre-select a sketch and then create an in-place part, I want it to create a sheet metal on sketch, for example, or an extruded component, or whatever. Okay. If I select nothing and start my in-place part, I want it to dynamically go into the contour. Okay, so let's see. Are we done? Nope, we're still thinking. So let's see if I can kill this so we can get back to it. Or, here, we'll do it this way. It'll be more fun. Launch another session. Keep going. This way we can talk about the last two features, okay, because I think it would be nice to see these things. So give me 2 seconds as I launch this up. Peruse the questions to see if there's anything else that needs to be answered live. I don't think so. All right, cool. We're back. Let's bring this back. That. Back to our assembly, and we'll go to the distribution sample. Okay, so real quick, with regards to doing the distribution, so here's my distribution pattern, and here you have an orientation of normal or vertical, and you can see the vertical just sets it to be upright, which is great. The distribution command, if you're not familiar with it, is a super intelligent command for keeping everything distributed cleanly and uniformly. Okay, so you have that. And then if we go talk about our in-place design, let me just go grab this really fast. So in my template for my part document, if I go up to my part template here, and I go to my options, add that on here, minimize that a little, go into general, you'll see default commands for in-place parts. Okay, so again, when I've selected a planar face, do I want to go to make a contour on it, or I want to use the constraint block command? I'll leave it as constraint block. When I've selected a sketch, do I want to make an extruded component out of it? Do I want to create a sketch or sheet metal on sketch, for example? Okay, so let's do sheet metal on sketch in that case. And if I have nothing selected, let's just create a contour. Okay, so let's see how this works. Save that. Back to there. And I'm selecting my face. And here I'm going to create an in-place part. And I'm going to use that template. And it's going to go directly into my constraint block command. Right? So then I can do whatever I need to do to make my constraint block. Click OK, I've done, and I've created my part. If I go here and I create a sketch for fun, I'm just going to keep this nice and simple. Grab that profile. So I have a sketch selected, and I created an in-place part on that. All right, I'm still in my in-place part. Let me do that again. Let's create my sketch here. And we're just going to copy that profile. Perfect. So now if I select my sketch and I do an in-place part, again with my custom part template, notice it goes straight into my sheet metal on sketch, because this way I have my sheet metal, and then I can go here and I can add my flanges, right? I don't want my flange to go the other way, and I want to add this flange, okay? And who knows? And you're moving on with your assembly, okay? And then if I just create a sketch for an in-place part in space, right? Now it's going to ask me for a sketch plane because it's going to go straight into my contour command, and boom. So again, the idea is you can just capture some of the more basic things you do with an in-place part and really control what command is launched to help get you started with that new design. Okay? So we're going to make a widget there. Extrude the widget. We now have a new part, and we've made our 3 new parts nice and quick and efficient. Cool. All right, let's go ahead and close that stuff down. Alrighty. Let's go back to our presentation. All right, so now in families, okay? This one, it doesn't really need a live presentation. If you've worked with families, it should make sense to you. First of all, the tree structure of the parameters folder is now retrieved in the generics folder of the family document, okay? So whatever you have and however you've organized your parameters here are going to show up with the same organization inside the family document, which makes it significantly simpler to continue working and looking at things the way you've already organized them in the parent document, okay? At the inclusion of a family, the drivers can now be updated manually. In other words, you can type the new values in and hit update and watch them update before committing to that updated change. Okay? Alrighty. That's it for families. If we go to our bill of materials, I think there's only one little point or two here. Just a couple little enhancements. You can now, it now allows grouping and subtotals of the grouped objects, okay? And then it allows you to perform an operation, simple or complex, from the contents of the existing columns. It can be text or numerical. So, for example, the total mass is quantity, right, times mass would be an example. So you can start using equations in here as well, okay? Cool. Well, that's it for this webinar. This one was a little bit shorter. The next one starts at 3 p.m. and we'll continue going through some more of the design new features. Does anybody else have any questions that weren't answered that would like to get answered before we call this one complete? So just type it in, and again, we'll do our best to answer you all. I don't see any, so I'll say we'll see you guys shortly at the next webinar. Talk to you soon.